Okay, hi everyone. We'll go ahead and get started. Win will talk to us first about the iDDS project that's, I guess, happening between IRIS-HEP and Atlas in this case. So go ahead, Win, and we'll interrupt you with questions or wait to the end, depending on how people feel.
Okay, so today I will talk about intelligent data delivery service, iDDS. My name is Guan, and from Wisconsin University. Its work is supported by IRIS-HEP and Wisconsin. The main structure for today's presentation, the first I will introduce iDDS, include the main architecture, the DAG support in iDDS and the monitors. And then I will introduce the iDDS achievements for different use cases. For example, data cursor, HPO, LSST exercise, and active learning. And then after that is the summary. iDDS is a joint project with IRIS-HEP and Atlas. It's an intelligent service to transform and deliver needed data to consumers. It is designed to orchestrate of WFMS and DDMS with generated workflows. At the beginning, for the iDDS design, it's experiment agnostic based on function generalization. It extracts and abstracts the functions for orchestration. And it's maintainability and extendable with a plugin structure for in iDDS. Here is the main structure of iDDS. The header service is a read service to accept the request from the client. After that, it has several different demos. For example, the clock to manage requests and the marshal to manage workflows. The transformer to manage the transformation, and the carrier is used to submit the transformation to different transformation backends. For example, Panda, Russia, and Condor or something. The conductor is used to send a message to different scheduler backend to trigger subsequent work steps. Here is the main structure of iDDS. Here is the detailed structure. At first, iDDS is a client-server architecture. The REST server is used to handle requests from the clients. It employs different backends for transformation. For example, Panda, Russia, Condor, and so on. The server is a layered architecture. Every layer abstracts a group of functions. This structure hidden the complexity of different logics on different layers. And for the iDDS task management, it's a workflow-based task management. In iDDS, a workflow is a group of work and their relationship. One work is a transformation task for different experiment and use cases. Different work can be defined or developed. Here is the main structure of iDDS layered structure. At the bottom is the database. On the database, it builds the ORM layer to manage DB operations, the core layer to generate the logical function and components. The API provide API function for different demos and for the REST server. And the plugin structure is based on the workflow. The workflow plugin structure is used to extend the can be used to extend that for different use cases. iDDS has two different DAG workflow management. the first one is the task level tag management. In this model, the relationship description is among tasks. So when there are new outputs in a task, new jobs are generated for dependent tasks. When a task is terminated, dependent task is triggered. There's another tag management is job label tag management in iDDS. In this model, the relation description is among predefined jobs. And the job is this one, the jobs are grouped based on WFMS. When a job is terminated, iDDS will trigger to release dependent jobs or terminated the workflow. For iDDS, we also developed several monitors. Inside iDDS publish a message to, and many monitors can consume the message to and to build monitors. At a current stage, iDDS, there are two types of monitor. The first type is a persistent state monitor. It's used to monitor the task status. For Atlas, we have a big panda monitor, graph monitor, and Elasticsearch monitor. The big panda monitor is built directly on iDDS database, so it's a real-time monitor. We also build a service health monitor to monitor whether iDDS is in good whether iDDS is running in good health. It's based on Elasticsearch. We can monitor the CPU and the memory usage. For monitor, we are planning to construct one experiment agnostic monitor because for iDDS iDDS can be used for different use experiment, and so if we build a new instance, we wanted to have a monitor attached with the new instance. So we are working on this part. Here is the main iDDS achievement for different use cases. The first one is the data cursor. Data cursor is what is in production since May of 2020. It is used to solve the issue with the delayed start of persistent data on tape. Another use case is the hyperparameter optimization, is to provide a full automated platform for hyperparameter optimization on top of geographically distributed GPU resources on the great HPC cloud. This is already advertised to Atlas machine learning users, but it's not specific for Atlas. And it's also not specific for machine learning. For example, recently we are talking about to use HPO structure to run toy monocolor. The third use case is job labor tag management based job labor tag management workflow. We use the Duma Panda instance for IRIS-HEP exercise. IRIS-HEP is a cassette of a trend of a multiple step persistent with thousands of jobs per step. With iDDS, it can release the jobs incrementally for different steps to avoid long waiting. Because without before for IRIS-HEP, it is using a task-based management. So in that case, normally the job will not be released until one task is finished. So with iDDS, we don't need to wait the task to be finished. We can release the jobs incrementally for different steps. Another use case is the task level tag management workflow. In this use case, high-level workflows are specified by tags, driving workflow scheduling. And we use this one for active learning for Atlas dynamic task management. In this workflow, new tasks can be generated based on the analysis results of previous tasks. Okay, so now first I will talk about the iDDS data cursor. It's a fine-grained data cursor use case. iDDS works to orchestrate rules to collect and digest file information, and then send a message to Jedi and Panda. And after that, Panda will process only the pre-staged files with the proper granularity. And instead of processing with dataset level granularity. In iDDS data cursor part, iDDS work to trigger to process the data based on the message from iDDS. Here is the structure. This part is the file management, data management managed by rules. In iDDS work, iDDS at first get the information and collect that information from the rules and send a message to Panda and to Jedi and Panda to release jobs immediately when a file is staged. For iDDS data cursor, it had been in production state since May 2020. It has processed about 21 PB data, and it also reduced a lot of redundant job attempts. Here is the here is the data 15 with iDDS. Here is the data 16 without iDDS. With iDDS, the number most of jobs can be finished with not many attempts. The second use case is the iDDS HyperParameterOptimization. For this part, it's designed to provide a full automated platform for hyperparameter optimization. Here's the structure. When one HPL task is submitted to iDDS, at the first, iDDS generate hyperparameter by iteration, and the hyperparameter will be sent to Panda, and the hyperparameter will be evaluated on distributed resources. The results of hyperparameter evaluation will be reported back to iDDS based on the previous results. Every iteration, new hyperparameter are generated. So with the coordination of iDDS, hyperparameter generation and processing and optimization can be automatically on distributed structure. iDDS is for iDDS HPL is already advertised to Atlas machine learning user, but it's not specific to Atlas. Here is the monitor Here is the information from iDDS Build Panda Monitor. You can see the usage of iDDS HPO is increasing, and for iDDS HPO there are some also many advanced use cases. For example, in this month, we has a present one use case is the segmented HPO for distributed training, and for HPO recently we also discussing about to use it for toy immunocolor. Another use case is for iDDS is IRIS-HEP exercise. It's a job labor tag. In IRIS-HEP, at the first, thousands of jobs are defined, and the dependency is also defined. And in this case, we at first group the jobs to tasks based on the dependency to adapt Panda task to adapt the workflow to adapt the WFMS Panda task management. iDDS manages the dependency and triggered to release jobs incrementally when all dependency for one job is ready. In the other use case, normally we will block a task until the previous task is finished. So for example, in this example, we will block task 2 until all jobs in task 1 is finished. So it will some jobs will have to wait for a long time. For IRIS-HEP exercise, we use the experiment agnostic Duma Panda instance, and we also deployed a new iDDS instance for it. We already test various workflow with the cascade of jobs. And last week we had a scale test based on iDDS and Panda. Here are 2 examples of iDDS IRIS-HEP exercise. Another use case for iDDS is iDDS active learning. For iDDS active learning is a simple simple task-based task labor tag management workflow. It used to train, process, and learning tasks. In this workflow, we have two different tasks. Two different types of tasks. One type is the processing task, and another type is the learning task. The processing task is based on the decision making of the learning task. And the task template is defined to generate constant tasks, and the condition branch is used to control the workflow whether we need to generate a new task or we just terminate the whole workflow. So for this use case, the current state is under integration with Panda. Okay, here the summary of the iDDS current status. The main structure is already deployed for use for a long time, and at the current state, frequently we also work to improve the main structure. Here you can find the document and monitor from different places. The homepage and the code is in GitHub. the document is in reader docs. And for Atlas, we also have the big panel monitor. And for this part, we're also working to develop different monitors to for iDDS, we already deployed two production instances, one is Atlas, one is Domo. And we also have one instance for development and integration, and also for new or some not well-defined use cases. For iDDS, we already be able to support the fine-grained data course use case, HPO using IRIS-HEP exercise, and the active learning. For the future, we will also work to improve the main structure, and we want to work with in recent plan. We wanted to improve the monitor, and at the same time, we also started to think about to develop to adapt for new use case, for example, for the tau in Monte Carlo, and for the dynamic transformation and placement on demand, or for the fine-grained data transformation on and delivery, for example, for even a streaming service. Okay, that's all.
Well, thank you. Very nice. Other questions?
Yeah, so I'm sorry. I mean, maybe I came in a bit late. What's the motivation for this work? I mean, is this? I mean, this looks like another workflow management system. Is there? I mean, what features does this have that aren't available in other workflow management systems that we're using right now?
Yes. So at first, we have the rules to manage the data. We have Panda JDI to be the workflow management service. But for them, for example, for Panda, frequently we added some functions for different usage, but it makes the system some functions are not really generalized. So for different use cases, we may have different requirements. We needed to orchestrate. We need a service to orchestrate WFMS and DDMS to connect that information between each other to improve, to trigger the processing, for example, fine-grained workflow or something. That's why we wanted to have iDDS to work between DDMS and WFMS to be intelligent delivery.
So this is orchestration between Rucio and Panda to get them working together better. Is that a good summary? Yeah.
Yes.
Can I try a short version? This is Tori. The way we've used Panda previously, you sort of assign it a block of work at a reasonably coarse scale, and you send it away. Pilot picks it up, and apart from heartbeats, your next interaction is when the job is done. iDDS was developed first for a use case that we're not even actually using yet, which is analysis on the wire, where you have analysis data sources that are in some central store and need some sort of pre-processing before you deliver it on a wire, because we typically use like 10% of the data actually in analysis. So you want to deliver ideally just that 10% to a client, with iDDS being the agent to progressively be delivering small chunks of data through a cache and to the client as execution proceeds. So you're processing in real time. You're not waiting for some transformation to happen and complete. And then when we had this, where you have a central service that is providing fine-grained communication with a client on the basis of special information that it knows, that the central service knows about how the processing has been proceeding in the course of a job, you can make use of that information as the job proceeds dynamically to drive the workloads that are carried out by this larger scale job. So this kind of use case where you're adding fine-grained intelligence and decision-making on the basis of what happens in the course of a job to affect the rest of the job is what we found really useful in iDDS and new above what, in our case, Panda offers on its own and RootsScale.
Okay, thanks.
Anybody else with questions? I can ask one while you're waiting. I was curious how you're defining, you talked briefly about scale tests. I was curious how you're defining those, how you're defining a relevant scale for those tests. So you think about sort of the scale that you'd like iDDS to be used in HL-LHC? Is that the sort of scale you're trying to test, or something more modest?
For the scale test, recently we did it for DOMA, either for IRIS-HEP exercise. For this part, one part is also dependent on the IRIS-HEP cluster. And in this part, we want iDDS to be able to release the job as soon as possible to occupy the IRIS-HEP cluster.
If I can add,
okay. Yeah, go ahead, Tori.
LSST, maybe surprisingly, has workflow management demands of basically the same scale of Atlas, mainly because their jobs are shorter. So even if the aggregate processing is not Atlas scale, sort of the processing management and bookkeeping and workflow management handled by iDDS is. So like the scale tests that are going on this month for LSST are part of a program to exercise what is a challenging scale because it is comparable to Atlas.
That's just saying that their DAGs are more complicated than what Atlas typically has.
Yeah, and the granularity is finer. You know, the individual pieces of work are smaller, so
right.
the bookkeeping job is bigger. Management job.
Good. So that means they're doing the job for those of us on the HL-LHC side of things.
Yeah.
Anyone else with questions? Okay, thanks again, Win.